In the next few minutes, we hope to achieve three things. One, you need to know when something is inversely proportional. Two, you will be able to find the value of k, the rate of change or constant of proportionality. And three, you will be able to solve inverse proportion problems. Now let us look at this graph. This graph is said to be inversely proportional. Now there are some key features that you need to understand. One, it must be in the first quadrant. And two, it never touches the x-axis. And three, when one quantity is decreasing, the other one is increasing. So if you notice here, as x is decreasing, the y value is increasing. This symbol here, alpha, is often used as a proportional symbol, and it is used to describe the relationship between two quantities. So for example, on this graph, we can use it to describe the relationship between x and y. Y is inversely proportional to x, so we would write y and we use this symbol and we put 1 over x. In mathematical terms, it means that y is equal to some value or constant k times 1 over x. Or you can write y is equal to k over x. So from this graph, we should be able to find the value of k. So let's write y equals to k over x. We can pick any two values on this graph to work out the value of k. Let's say, for example, we have this coordinate here. So here we have 2, which is the x value 2, and the y value is 10. So it means that we can put in the equation here y as 10. So we have k over x, which is 2. So it means that k is 2 times 10, which is 20. So it means that we can write our equation y is equal to 20 over x. We can use this equation here to work out any value on the graph here. So let's say, for example, this is 4, 5. This coordinate is 4, 5, so we could use the equation there to work it out. So we know that this is 4, 5. So what this is saying is that when x is 4, y should be 5. So if you put 4 in here, 4 into 20, you would get 5. Let's choose this value here. When x is 1, y should be 20. And that's true as well. 1 into 20 goes 20. So that's the equation. Now let us look at some problems. Solving some problems. So here we have a question. Y is inversely proportional to x. So we're going to write y is equal to k over x. Given that y is 10 and x is 4, find k. So y is 10, so we input 10 there where y is, and we have k over x. X is 4. So it means that k would be 4 times 10, which is 40. So we can write our equation then from this. Y is equal to k, which is 40, over x. So here k would be 40. Now b, find the value of y when x is 8. So here y would equal to 40 divided by 8, and that's 5. Find the value of x when y is 20. So in the equation here, we can find the value of x when y is 20. So y is 20. We're using this equation, and we have 40 over x. Let us multiply both sides by x. So it means that we would have 20 times x, or 20x is equal to 40. So it means that we can divide both sides by 20. So x equals 2. So this value here, x is 2. X equals 2. Let us look at another question. Here R is inversely proportional to T, so we can write R would equals to K over T. So first we're going to find K. So R is 12 and T is 0.2. So we input 12 there in the equation. So we have K over the value T, which is 0.2. So here K equals to 2.4. So now calculate the value of R when T equals 4. So R equals to K, which is 2.4, all of that over T, which is 4. So it means that R equals to 0.6. To further consolidate your understanding of inverse proportion, here we have a table and you're required to draw a graph. The pair of variables x and y are inversely proportional. The equation linking the variables is y equals 12 over x. By completing the table, draw the graph of y equals 12 over x. So the first value is worked out for you. So here x is 2. So all you have to do is to substitute x in this equation. So 2 into 12 here would give us 6. So the y value here would be 6. And here 3 into 12 would give you 4. Let us plot the points. First we need to label our axes. So this is our x-axis. And that's our y-axis. So our first point there is when x is 1, y is 12. So we identify 1 here and we go up to 12 and we plot our first point there. When x is 2, y is 6. That's our next coordinate there. And when x is 3, y is 4. So that's our next coordinate there. So here we have the graph of the equation y equals 12 over x. So let's label it y equals 12 over x. When y is increasing, the x value is decreasing. The general equation for things that are inversely proportional is of the form y is equal to k over x to the n, some value of n. So with our equation here, y is equal to 12 over x. Here, k would be 12. Next thing we need to note is that it's a reciprocal graph. And it's always smooth. And it has to be in the first quadrant only. And it never touches the x-axis.